So this first one is exponential. That's the first thing you have to realize because they're going to get grouped together. Obviously, it's exponential. There's no log in it. There's no log and no ln, so it's exponential. When you're looking at your exponential functions, the first thing you want to identify is if there's a vertical shift, and there is this time. This is a shift down 3 places, which means that your horizontal asymptote also gets shifted down 3 places to y equals -3. Which means you've got a horizontal line running through, a dashed horizontal line running through where -3 is. If you didn't graph your asymptote on your graph, you need to start doing so, okay? It will be part of what earns you points on a question like this on your test. Then from there, you can plug in to fill in your t-chart. So for the exponential, we plug into x. I would get 4 to the -1 minus 3, 4 to the 0 minus 3, 4 to the first minus 3. And again, most of you did that right. The 4 to the -1 would be 1/4 minus 3, which is -2 3/4. 4 to the 0 minus 3 is 1 minus 3, which is -2. And 4 to the first minus 3 would be 4 minus 3, which is 1. You missed this conversation like 3 minutes ago. Something glitched when I took a screenshot. I can't fix it because it looks like it's centered on mine. So your graph might be off, but the rest of it is what I graded. Okay, so then I'm going to go to my graph and I'm going to plot these points. So -1 and -2 3/4. 0, -2, and 1, 1. The domain on all exponential functions is -infinity to +infinity. The range is adjusted by that vertical shift. So because it's shifted down 3, your range starts at -3 and goes to +infinity. We already found the horizontal asymptote. And then the y-intercept is when x is 0, which is 0, -2. Questions on it? All right, so now we're dealing with a log. With a log, you're worried about a horizontal shift, and that's what is inside the parentheses. This is a shift to the right one. You can either obviously know the rule that it goes in the opposite direction, or you can set what's inside your parentheses equal to 0 and solve. And that's where you can get your asymptote from. So x equals 1. Be careful. Make sure it's x equals on the logs. On the exponential, it has to be y equals. You will lose points by not making it the equation because it's a line. So I have a vertical asymptote that runs through 1. Okay, so then the graph, in order to convert this into exponential, which is what I'm going to eventually do, I have to isolate the log. The parentheses stays there, but I have to get rid of this -2. So the f of x is really y. And then I'm going to add the 2 so that I isolate the log. Wow. Come on. Then the 2 comes over and picks up this whole exponent. And then I add the 1. So I get x equals 2 to the y plus 2 plus 1. And then for logs, we plug in for the y. So I'd get 2 to the -1 plus 2 plus 1. 2 to the 0 plus 2 plus 1. And 2 to the first plus 2 plus 1. So I get 2 to the first plus 1, or 2 plus 1, which is 3. 2 to the second plus 1, or 4 plus 1, which is 5. And 2 to the third plus 1, or 8 plus 1, which is 9. Then I go to my graph, and I have 3, 1. Oh, sorry, 3, -1.
So you still graph it at the -1, 0, and the 1?
Yeah, you can plug in more points if you want, but this should get enough to at least know the shape. 1, 2, 3, 4, 5, 0, 6, 7, 8, 9, 1. So because I know that the log is supposed to turn and curve along this, you could literally do that. Or if you wanted to see the curve happen a little bit more, you could plug in, I would want to plug into the left. So like if I plugged in -2, I'd get 2 to the -2 plus 2 plus 1, 2 to the 0 plus 1, 1 plus 1, which is 2. Wait, did I do that right? -2. Yeah. So then I would get, that was on the bottom. So it'd be 2, -2. And now you see that curve happening a little bit more. So if you want to plug in extra points, you can, but as long as you know that that curve is going to turn, that's why the vertical asymptote is so important. If you know that that curve is going to turn at that vertical asymptote and hug it, then you don't need, as long as you have those 3 points, you're fine.
Does the 2 not push it up?
It's the x is 2, but the y is -2. So it's this point here. Yeah, it points it down, it pulls it down. And then your domain is now restricted. So with logs, our domain is restricted. It starts at the vertical asymptote. It points to the right. So this would be 1 to positive infinity with a parentheses on both. The range for logs is -infinity to positive infinity for every single one. And then the x-intercept comes from when y is 0. So that's 5, 0. So if you haven't already exported it out to Notability, if you want to export that out to Notability so you can save it, those are obviously good practice problems for both your quiz and your test.
What was the domain for the first question?
All real numbers. For exponential, finish those last. Really, it's one more slide. We've talked about 2 slides, but really one more slide of examples that we didn't finish from 5.2. So in 5.2, we did the graphs of logs, then we did the graphs of ln, and then we did conversion from exponential into log to exponential, and those like mental math problems. Today we're going to talk about evaluating with ln. At some point it will change. All right, so yesterday we talked a little bit about ln's, really just the graphing part of ln's. We did say that the ln is the same thing as log base e. So when you see the word or the letters ln, you can immediately swap it out for that. Because log base e, because ln is log base e, if I had ln of 1, it would be the same thing as saying log base e of 1. And anything with the big 1 next to it means that that would have to be raised to the 0 power. So that's 0. So just like log of 1 is 0 and log base 10, or base, change it, 7 of 1 is 0. Okay, the same rule would apply to ln because ln would be log base e. Because it is log base e, if I say ln of e, that's like saying log base e of e. And if the base on the log and what's next to it are the same, that answer is 1. So if it was log base 5 of 5 or log base 3 of 3, it would all be 1. If it has any other exponent other than 1, then the answer is just that exponent. So if I have ln of e to the 3rd, let's say, this is the same thing as saying log base e of e to the 3rd. And when the base and the base on the exponential function repeat, you literally disregard them and just keep the exponent. There is a long process around that. When we get to an example, I'll work through it, but hopefully that's something that's easy that you remember. ln of e cancels out and leaves you with its exponent. And then just like the one-to-one property with logs works, the one-to-one property with ln's works. So if I had ln of 3 equals ln of x, I ignore the log because that would be the same base, and I would say x equals 3. So one-to-one property says if there's an ln on either side of the equal sign, just like if there's a log on either side of the equal sign, you can disregard it and you can stick with what's next to it. So there was a lot of one-to-ones in the homework at the beginning. All right, we're going to work through these. All right, go to 29. So there's a couple different ways to do this. Okay, and the better you are at the understanding of the mental side, like the mental math part of this stuff, the faster you are, the easier it's going to be to take that test or that quiz because these should be fast. The first way to do this is say that this is the same thing as log base e of 1 over e equals x. And then I can convert this to exponential. E to the x would equal 1 over e. Yep. You can move the e to the top, making it e to the negative first. Again, this would be the long way around. And now my bases are the same, so x is negative 1. I hope you never have to do that again, though. Because if I look at just the left side of this, right? I know ln is log base e of 1 over e, right? And I'm asking, what do I have to raise e to make it 1 over e? In order to move something to the bottom, it's negative 1. So x would be negative 1. You will see this without the x. Like, you'll just see just that side, kind of like what we did yesterday on the booklet. A lot of times you'll see it just like that. And again, no work required. It's negative 1.
What if it was like 5 instead of 1?
It doesn't work.
No.
No. So this one is the reverse. This one has the e in the base of the exponential function, but this would also have log base e in the exponent of it. Remember, if the base and the base match, you can literally cross through it, and you keep the 5. Now, the long explanation of that is if I were to take this as exponential and if I were to convert it to log, I would get x equals log base e of ln. Nope, sorry. I'm going to move it around.
Oh, so the base comes before that ln?
Log base e. So this is the base on the exponential. It would be the base on the log. And these would separate. So this would equal, this is still log base e of 5. Log base e of 5, and then the x comes to the other side. And then you've got the 1-to-1 property that says x equals 5. But you shouldn't have to do that. Like, if the base on the exponent is the same as the base on the log, they cancel out.
So you would cancel out log?
Yep, because it's on both sides. Go to 31. What is ln of e? Log base e of e. And what is that?
1.
That's 1. So you don't even have to write log base e of e. You know ln of e cancels out and gives you the exponent. And really, there's a 1 on that e, right? So this would be 2 times 1, which is 2. ln of e cancels out, leaving you with the exponent. Go to 32. What would be ln of e to the 1/3? 1/3.
This can only work when it's ln e.
Correct.
Not log e.
Correct. Now, if you didn't, again, you can rewrite it as log base e of e to the 1/3 equals x. And then I could convert this into exponential. E to the x equals e to the 1/3. And then my 1-to-1 property says that those exponents equal to each other. But you don't have to do all that work if you know the property well enough. All right, go to 33. What is ln of 1?
0.
0. So 5 times 0 is 0. If you had a calculator, you could actually just plug that whole thing in. It will give you 0. Like 5 ln of 1. But most likely on a question like that, you're not having your calculator. All right, 34.
3/4.
Good. It would be 3/4 times 1, which is just 3/4. And 35? 7. So easy if you understand the properties. If you don't, you have to go through the extra work. But if you can practice it again and understand the properties, these should be actually super easy, fast, and not a lot of work.
You're spending like 30 and 35. I don't understand what like being the bottom person.
35?
Yeah.
So this is in exponential, even though there's a log in that exponent. This is exponential because you have something raised to a power. So if I wanted to convert it into log, I would do log base e. Remember, they separate, so this would be equal ln of 7. And the x comes on the side with the log base e. So if I'm converting, that would be if it's exponential and I'm converting to log.
Oh, because there's log on both sides.
Now there is.
Okay, yeah.
So then this is log base e of x equals log base e of 7, and now x equals 7.
Okay.
Yep.
What if there's 3 e's?
What do you mean?
So like, since it's log of e to the 7th right there, there's 2 e's, so I assume that's why it cancels out.
Like log base e to the 7th, like that?
Yeah.
Then it would just be 7. And you couldn't use the 1-to-1 property on it.
No, but what if there were 3
So if this was like this, is that what you're saying?
Yeah.
Then x would equal e to the 7th. It will eventually pop up there. So a lot of the questions at the beginning of the homework use the 1-to-1 property on logs. Remember the rules: if the same log is on either side of the equal sign, you just ignore the log. You set it equal to each other. Same for ln's, okay?
Are we ever going to get, like, x equals e7?
Sure, you would leave it as e to the 7th if you didn't have a calculator, and then with a calculator you would actually find e to the 7th. Yeah. All right, and then this was, what number was this, Hallie? 5 from the homework? Yeah.
We don't have to do, like, all that work.
Nope. Yep. The payoff of logs is if you understand the properties, they're so easy. Not all of them are going to be that easy, but all that meant this is like when the mental math pays off, because if you understand the property, it actually avoids a lot of work. A quiz? Well, we will eventually get there. Yeah. Okay, so this one wants you to graph it. So I would first change it to y equals log base 3 of x plus 4. That plus 4 is not in the parentheses, so the plus 4 is a vertical shift, which means that my horizontal asymptote is at, my horizontal asymptote is at x equals 0.
It's going to be reflected, right?
The negative's going to flip it upside down, yeah. I'm going to first isolate the log, so I have to do y minus 4 equals negative log base 3 of x, and then I also have to get rid of that negative. So negative y plus 4 equals log base 3 of x. You have to completely isolate the log first. 3 picks up this whole thing, so 3 to the negative y plus 4 equals x. And then you plug in. 3 to the negative 1 plus 4. 3 to the negative 0 plus 4. And 3 to the negative 1 plus 4. So I get this would be positive 1 plus 4, 3 to the 5th, 3 to the 4th, and 3 to the 3rd.
Wait, why is there an 11 in the first one?
It's negative 1, so it became 1. It's not 11. It's just, yeah. So this is 27, this is 81, this is what, 243? Yeah. So obviously I wouldn't expect you to graph 243. 243 would be at negative 1. And then 81 would be at 0. And then 27 would be at positive 1. And you could plug in more points. I would need to plug in points to the left, so I would do negative 2, negative 3, whatever I would need. Or you could just know that your curve is going to hug the vertical asymptote and point down to the right. So the domain is 0 to positive infinity. The range, because it's a log, all real numbers. The x-intercept is 81, 0, and your vertical asymptote was at x equals 0. So again, if you wanted to plug in smaller numbers, we're talking smaller numbers by way of the y. So I could plug in negative 2. I could plug in negative 3. I could plug in negative 4 if you wanted to see it come back up. But as long as you understand that that curve is coming up when it gets closer to that asymptote, you don't need to plug in those points. questions?
This class is at 9:05.
9:10.